Hello everyone. Today's topic is distance vector routing algorithm. So, what is meant by routing and what is meant by algorithm? Routing means whenever the packet comes from any node in a network layer, it has been decided that in which route packet should be forwarded. So that process is known as routing. And algorithm, even algorithm is called as protocols. Okay, so what is meant by protocol? Protocol is nothing but a set of rules or defined rules which are used to route any packet in the current direction. It is known as protocol or routing protocols. So that is called as routing algorithm. So this routing algorithm has been divided into two types, static routing algorithm and dynamic routing algorithm. In the static routing algorithm, it is a form of routing that occurs when a router uses manually configured routing entry. It means static means like constant, which never changes. That means that whatever the values are there in our routing table, it never changes. It will be like manually, randomly, it will be same as it is. Whereas dynamic routing algorithm, every time the values in the nodes or value in the routers will be keep on changing. So that is called as a dynamic routing algorithm. So this dynamic routing algorithm, that is even called as distance vector routing algorithm. So in this distance vector routing algorithm, it is they used some protocols of Bellman-Ford algorithm. So even this algorithm is called as Bellman-Ford algorithm. So why we are using this distance vector routing algorithm? So why we use this means routing protocol is used for forward the packet from source to destination by using the best route. So what is meant by best route? Best route is defined as per the distance, cost, speed. So we should find the optimal path or the shortest path. Means we need to find out the shortest path from where which has to be traveled. So here are the some steps how to solve our or how to do our distance vector routing algorithm. So step 1, each router prepares its routing table by their local knowledge. What it means, so routing table is prepared for each and every router. A routing table is prepared by how they will be checking whether all the routers are present in the network, and they'll even be checking like what is the distance between our neighbor nodes, like what is the distance between our node and the neighbor node. This is the step 1. First they will be checking in that. And what is the step 2? So each router, after checking the distance, it exchange a distance with the neighbors, and then each router prepares a new table. So after exchanging the distance between the two routers, it will prepare every new routing table. So whenever it visits to the neighbor router, it will prepare a new table. So it is obtained from the neighbors. So how many times it should prepare means we can be repeated like n number of times. So this step is repeated for n minus 2 times if there are n routers. So it depends upon the routers, how many routers are there. If there are 4 routers, you have to work like 4 times. So after once the routing is completed, a new routing table is prepared, and that routing table will be stable. So I'm taking here an example of 4 routers here. So there is a network consisting of 4 routers. So the weights are mentioned on the edges. Weight should be distance or the cost. I mean to say it may be called as your weight, or it may call it as a distance. You can call it as a distance as well as the weights you can consider. And routers means A, B, C, D. These are the 4 routers, and these are the cost or distance. You can call it as anything. So first basic routing table for each router. Okay. Now the basic routing table for each table we will be drawing here. This is my diagram. Okay. For router A we are now. So how your table is traveling from to the all the routers. So first one is called router A. So we are doing here. So first one from A to A, how many times it has been traveled? So A to A doesn't travel. So A to A nothing but 0. Then we have to write here all the routers whatever are present in our table. So like A, B, C, D. So A, B, C, D. Okay. Then from A to A, how many times it has been traveled? So nothing but 0. So A to B. A to B, how many times it has been traveled? Or what is the distance between A to B is 2. So we have written here 2. A to B. Because it's a neighbor node. We have written here neighbor node. Like next hop. Next hop means next node. So C to A or A to C. This is router A. So A to C. A to C, is there any direct link? No. So there is no direct link from A to C. So I have written here infinity. Okay. There is no next, like there is no neighbor node. So I have written like nothing, nil. So again from A to D. A to D is how much the distance? 1. So then what is the neighbor node? D. So I have written as D. Same as for your router B. Now we are going with the router B. Now B to A. We have to find from B to A. What is the distance? 2. Again B to B, how much the distance? It won't travel from B to B. It is 0. Okay. Now again from B to C. We are checking from B to C. What is the distance between B to C is 3. So I have written here 3. And the neighbor node is C. So I have written here next hope as C. And then B to D. B to D. That is 7. So I have written here as 7. And the neighbor is D. Okay, this is a routing table of B. And next, now A has completed, B has completed, we have to go with the C. So router C now. We need to draw a table of router C. Again, all the same as this ABCD, we have tried the what do you call routers here. Again, C to A. So A to C is also nothing here, and C to A is also nothing here. So C to A we has not traveled anything, so I have written infinity. Okay, now C to B. C to B, 3. So I have written as 3. Next neighbor is 3. So, sorry, neighbor is B. So I have written the router name as B, or the node name is like B. And then C to C. C to C doesn't travel. So nothing but 0. Okay. Then C to D. C to D is 11. So I have written like 11. That is called D. Okay. Now we have completed with the C. Now we have to go with the D. Again, router D now. Okay, and we need to check from the D. So D to A. What is the D to A distance is 1. So I have written here 1. Again, D to B. D to B. It is 7. So I have written 7. And the neighbor node is B. So I have written here as B. Again, we have to go with the C. D to C. D to C. That is 11. So I have written 11. So neighbor node is C. Okay, again D to D, will it travel? No, it doesn't travel from D to D, so I have written like 0. So these are the basic routing tables of each router A, B, C and D. Now, as earlier I said you that distance vector routing algorithm is used to find out the shortest path or the optimal path from the neighbor to neighbor, how much it has been traveled. So now till now we have seen the router tables of each routing tables. We have seen like A, B, C, D. Now we will see how much distance it has been traveled to the destination, from the source to the destination, and which is the shortest path, or which is the optimal path it has been traveled. So let me start with the A now here. So now we are going first, we are going with the A. Now we need to check from A to B. Now we have to take A to B. So A will become as source and B will become as destination. So we need to reach the destination B, and we have to see how many ways are there from A to reach B. So that many paths we need to collect it. Okay. So first path is A to B. Directly we can go here from, like, the path is A to B. That is 2. We have written the cost of this A to B, or the distance between the A to B is 2. So we have written as 2 here. Then one more path is there to travel to reach to the destination B. That is called A to D and D to B. So A to D, D to B. So that is called 1 plus 7. Here is 1 and it is 7. So 1 plus 7, 8. So there is one more path to travel to B or reach to the B, or one more path that is called A to D and D to C, C to B. We can travel. So for that 1 plus 11 plus 3. We should not go again with the A, because we are finding out into the A, and we should not go to the A, because we have reached the destination. We need to stop there itself. So A to D, this is a source and this is a destination. So A to D, D to C, C to B. We have to calculate the value. Okay. Now we have find out how it will travel from A node or A router. Now we need to check further from the side of B. Why we need to check means we need to check what is the value and what is the distance between our neighbor nodes. We need to check the how much it can what is the distance between our neighbor nodes, and we need to create a new router table for all the routers like ABCD. So we have done with the A now. Now we need to check with the B side now. Okay, then we need now A is completed. From A side we have seen now. Now A to B has completed. Now A to C we need to see. Now A will become as source and C will become as destination. Only we are creating a new router table from the side of A. So A to B is completed. Now A to D we have to do and A to C we have to do. Already we have completed A to B. Now I am going with the A to C. Now A will become source and C will become as a destination. So what are the ways to travel from A to C? So there is no direct connection anything here. So I'll travel from here. So A to D and D to C. So 1 plus 11 equals to 12. Okay, again one more path, A to B, B to C. I can travel from this way also. That is 2 plus 3 equals to 5. Okay, and there is one more way to travel. That is A to D, D to B, and B to C. We can even travel in this way, but we need to think the distance. How much is the distance? So 1 plus 7 plus 3. It is become as 10. So completed. Okay, this also. And then now we have completed with A to B and A to C. We need to go with the A to B. Why? Because we are find outing the distance between our neighbor nodes. For that case, we need to create a new router table for A. Now A to D now we are going. Again, A will become a source and D will become as a destination. Then A to D 1 and one more way like go traveling to D, A to B, B to D. So 2 plus 7, that is 9. There is one more possibility, that is A, B, C and D. So 2 plus 3 plus 11 equals to 16. Okay, with this we have completed of traveling to the neighbor nodes. From the router A, the neighbor nodes we have traveled each and everything. Now we need to create a table of new table of router A. Now tell me which is the shortest path from A to B we can take from among these three. This is the shortest path from A to B. Okay, so I have taken like A to A doesn't travel, so I have written like A to A is equals to 0. Now A to B, A to B. Again we need to write all the router names here as previous only. Now A to B, how much is the it is the least. What is the least one? A to B. So I've written here 2, and this one is called as a next node or next hop. Okay. Again now we need to go with A to C. See here A to C. Among these 12, 5 and 10, which is the least one? 5 is the least one. So I have written like C to 5. Okay. For 5, A to C for traveling. This is the least path, but traveling from A to B, B helped or B is a neighbor node. So this we have to write here next home neighbor node. Okay, and then again A to D. Now A to D, what is shortest path of A to D among these three is 1. So neighbor node is nothing D. So A to D is 1. So with this way we have created a new routing table. I said you earlier, once it will travel with the neighboring nodes and it will change the distance among them, then it will become stable. So now this is a new routing table. Now we have done with only from the side of A now. So let us go with the next one called as B. Now from the side of B we have A we have traveled. Now from the B we have to check the neighbor nodes and then we have to create again a new router table for B. Now again from B to A now. B to A. B will become a source and A will become as a destination. So from B to A, that is one way, or B to D, D to A, that is 7 plus 1 equals to A. Or if not, we can travel one more way, that is called as B, C, D, A. B to C, D to C to D, D to A. This is the source and this is the destination. And we need to calculate the value. Okay. Now we have done with the A. Now we have to go with the C now again. Now B to C. Again B will become a source, C will become as a destination. So first way B to C equals to 3. And next B to D, D to C. We can travel in this way also. B to D, D to C. Then 7 plus 11, we can write as 18. There is one more method to travel. B to A to D, D to C. That is 2 plus 1 plus 11. This becomes 14. Now we have done with A and we have done with the C. Now we have to go with the D now. Again, B will become as a source and D will become as a destination. So B to D, 7. And one more path like B to A to D. So 2 plus 1. Okay. 3. And one more way, B to C, C to D. So 3 plus 11 is 14. So this is one way. So again we have to create a new routing table with the 4 routers like destination A, B, C and D. So we need to think which one is the least cost or the optimal cost or the shortest path of this thing, and we need to write the values. So see from B to A. Now B to A. What is it? Which is the least one here among these 3? 2. So I have written 2. The neighbor node is A. So I have written here as A. Okay, now B to B. Will it travel from B to B? No. So I have written as 0 here. Then again, B to C. So B to C. Among these 3, which is the least one? 3 is the least one. So I have written a value of 3. And what is the next node here? C, neighbor node. I have written as C here. And the next B to D. Okay, B to D, which is the least among this path one is 7. Sorry, it's 3. So it is the least cost. So we have written as 3. And C, to travel from B to D, which is the neighbor node A. So I have written the next node or the neighbor node as A. Okay, from this we created a new routing table because B also has been traveled to its neighbor node and find out the least path to travel from B to all the other destinations. Okay, now we will go with the C, router C. Now we have completed A, B, and now we are going with the C now. Now we need to go with the C to D, C to B, and C to A. So first one, C to A. C to A. C will become a source and A will become as a destination. From C to A, there is no direct route. So we need to travel from C to D, D to A. So 11 plus 1 will become as 12. So one more way to travel from C to A is C to B and B to A. So 3 plus 2 is 5. And one more method, C to B, B to D and D to A. Again, we need to write the same values and we need to calculate here. Okay, now we have done with the C to A. Now C to B we have to see. Again, C will become a source and B will become as a destination. So we need to reach the destination source from two destination. C to B. What is the distance here? 3. Okay, again there is one more way to travel from C to B, that is C to D, D to B. Okay, so 11 plus 7. Okay, one more. Then again one more method or one more way you can call it as C to D, D to A to B. You can write. So that is called 11 plus 1 plus 2 equals to 15. So it has completed A and it has completed B. What is the remaining now? D. So C to D. C equals to source and D is equal to destination here. So C to D is what? C to D is 11 and C to, one more way to travel, that is C to B, B to D. That is 3 plus 7 equals to 7. And one more method is C to B, B to A to D. Completely we need to write like 3 plus 2 plus 1 equals to 6. Okay, again we need to create a new router, call it as C. Again we have to write all the destination like A, B, C, D, and then we need to now check from C to A. What is the value from C to A? Which is the least value among these 3? 5. So C to A is 5. So I have written here 5. But what is the next node? What is the next node for C? B. So next node will be B. Now then C to B. C to B, which is the least one among these 3? 3 is the least one. So I have written 3. And the next node will be like B. I have written here B. And from C to C, it don't travel from C to C. I have written like 0, nothing. Again C to D, C to D. See, this is the least among that. So I have written the value of D. And the neighbor node as B. So we have, with this we got a new routing table of C. So next one is D. Now new routing table for the D. Again we have to go, now we have completed here A, B and C. Now we are going with the D. So D has to travel its neighbor nodes A, B and C. So starting with the A. Again A will become a source, sorry, D will become a source, A will become as a destination. So D to A, 1, and one more method or one more way is D to B, B to A. So 7 plus 2, 9 here. Again one more method, D to C, C to B, B to A. So we need to calculate all the values here. So with this we have completed our A, neighbor A, and next D to B. Now next D to B, and D will become as source and B will become as destination here. Again D to B is 7, and one more method is D to C, C to B. So 11 plus 3, 40, and one more method D to A to B. So we have reached from the source to the destination. So 1 plus 2 equals to 3. Again we have completed with the A and we have completed with the B. We have to go with the C now. So D to C. D to C is what? First one, 11. D to C is. And one more method to go to the D to C, because source to destination. In this way also we can go D to A to B and B to C. So 1 plus 2 plus 3, 6. And one more method, D to B, B to C. 7 plus 3 equals to 10. So with this, we will be completing our values and we will be creating a new router D table now. So same as ABCD routers, we need to write all that, and we need to find out the distance between A and D, A to D. See, A to D is, what is the least value among these three? 1. So I have written like D to A is 1, and the neighbor node is A. So I have written here A. And next D to B. D to B is, which one is the least one? 3. So I have written as 3 here, and next node will be like A. Again D to C. Again D to C, which is the least one here? 6. So I have written 6, and the neighbor is B. D to C, the neighbor is B. The next one is what? B. So I have written A. We should not write A here because the next neighbor, so I have taken like B here. So D to D doesn't travel, so it is 0. So in this way, we need to create all the tables of router A, B, C and D, and it will travel to each and every neighbor node and it will create a new routing table, and once it will travel to its neighbor nodes, it will create a new routing table and the table will be stable. So here one more thing, identifying used links. See, after routing table conversion, so once the table becomes stable, okay, some of the links connecting connecting the routers may be never used. Maybe we have used the paths, maybe some paths have been left also. So in the above example, we can identify the unused links. So there are some ways which we even did not travel that one, or which are not that much important. What is that? Please check the diagram in the previous slide and then check this one also. The value of the next hop in the final routing table A. So in the routing table A, final routing table A, which is the least value we have in that means A to B we have the least value and A to D we have the least values. So these two will be used majorly because ultimately we need to find the shortest path, right? So for that case we use AB or AD. In the same way in the routing table B, we suggest only the edges BA and CB because these two contains very less values or the shortest path. Or in the next router C, we suggest only CB. You may be having other edges also, but we don't use other nodes because CB is very less or the shortest distance, so we will be using CB. In the same case for the D also, router D, we use only DA because it may be other nodes also, but we use only DA because it is having very less or what do you call shortest path it may be. So thus edges BD and CD are never used because one contains 7 and one contains 11, I guess. So these two are very huge values when we compare to the other values. So these two nodes or the two distance between AD and CD, BD and CD, we never use it. So in this way, we will find out the new routing algorithms. So this is called as distance vector routing algorithm. Thank you.